Alright, this is, welcome to my workbench. This is one of my first orders since the COVID shutdown, so thank you very much for the order. This is sent to me from, well, let's call him a patron in Chicago, so it's actually not too far from me. So I got sent in a Sega Nomad and 2 rechargeable battery packs. Fortunately for everyone, battery technology has advanced quite a bit in the last 25 years. These are actually nickel metal hydride short AA's. Got some corrosion on here, so at least one of the cells has failed. So I figured this is the first time I've actually worked with one of these. Now I have 2 of them to play with. The fortunate thing is these thick AA styles, these are technically B size cells. In case you ever wonder what a B looks like, it look like that. So these cells here are shot, and they weren't rated all that long. They'd only power up in Nomad maybe 2-3 hours tops. After like 16 hours of charging, you get maybe 2-3 hours of battery life off of it. So this one was sent to me to do a full upgrade on it, replace the screen, because the screens are pretty awful. Once I get it powered up, I'll demonstrate how kind of shoddy the screens are. No mystery here. I actually order all my parts from Console 5, which actually they're very quick shipping. I had no delays at all, which is really nice. Some of the items I need actually are delayed, so it's a little bit annoying, but it is what it is. But, these nice people actually came through. I like throwing business their way because they're actually quite good. So I ordered up new power jacks. So I'm going to replace the power jack on here. This is the audio video out. I replaced that as well. I also got a capacitor kit. I'll be replacing the capacitors on here. These are the surface mounts. This is the same style that's in there. These are little video connectors. I ordered a couple of screens, 2 for myself for fun. These are going to go into probably a I have a Gamecom where I'm tempted. I'm not sure if I'm going to go with this or an HDMI screen, but I'm going to build in a Raspberry Pi into one, and that should be. So that's a project for myself coming up. So I've got a screen for that. That goes aside. It's another same thing. Those are the cables that go with it. This is the one I really wanted. This one is, they called it the small board screen. Nomad's kind of neat. It's it actually has composite built into the board, so you don't have to do anything fancy in terms of like if you do a McWill for Atari Lynx or Game Gear, there's a lot of auxiliary wiring, especially the Game Gear's frankly a pain in the ass. And this one, I decided to go with this bracket, this nice 3D printed back bracket, which I don't know how it assembles yet. But yeah, there it goes. So it's a nice little 3D assembled bracket. Otherwise, I have to go through and manually like shave down some of the internal guts to the. Oh, isn't that cute? I have to actually go through and shave down plastic internally, and this is nice because looks like I can tuck this underneath just like so. Yeah, there you go. So I'll be able to tuck that underneath and have a nice little neat little setup, and it's gonna be a lot easier to integrate than I'm used to doing. Usually I'm in there filing stuff down. It's kind of a pain, so this wasn't that expensive and should work out really nice. The more interesting part is this. I'm going kind of crazy with the battery packs. What I like to do when I work on a project is I like to keep everything in one box together. So I have these nice like shoebox size containers, so I'm gonna put all my parts in one place so nothing gets lost. I don't need two of those out right now. These are mine, so I keep those. Pack those parts away. Caps, connectors. So for tonight, I was just going to show you. This is I opened up the battery pack. A little scratch there, but I'll buff that out. I found, of all things, a watch case back opening tool is the best way to pry this open without really scuffing it up too much. I'm going to have to go through with a little bit of Brasso once I'm done and just polish out the surface. It's very simple. It's 6 cells, so these are like 1.2 volts a cell, so you get 8.5-ish volts out of it. This is the existing charging circuit. All this is coming out. Let me grab the cells I'm going to use. I haven't gotten the new cells in yet, but I'll show you the size I'm using. These are leftover from other projects I've done. These are they call them 18650 Lithium-Ion Cells. These are neat because the power output of them now is crazy good compared to what they used to be. Even this one, I'm not reusing these because it's only 2600 milliamp hours, which isn't enough. I actually went out and found 9800 milliamp hours, so a crap ton of watt hours are going to come out of these. I'm guessing probably 24 hours of battery life, somewhere around there. Should be about roughly 9 times the energy density of these cells, so we should get 9 times the battery life, so 18-20 hours, somewhere around there. So but the nice thing is, since they use these nice thick cells, I can go in and pack in 3 of these side by side with only a little bit of, actually I might not need to manipulate it at all, because once I get the new cells in, they're not going to have this extra covering on there. Worst comes to worst, I'll have to shave just a tiny bit of plastic off of this just so it fits in this a little bit better, but they actually fit in there pretty flat right now. So what I end up doing is I'll have 3 of these 18650 cells here. I'll have 3 of them side by side, and I have this neat little USB charging circuit. It's about yay big. Again, something I'm still waiting for to come in. I'm going to have to mill out a little bit of plastic here, but the USB charging port will come in exactly where this DC used to be. So I'll have that charging port there, and I'll probably end up either wiring in the old LED for display. Well, I'm taking this and steal the LED off of it, or I'll like bore 2 little sight holes in here just to show the charge. There's a red light for charging, green light for good, and they'll have a little charging circuit, and so you just plug in standard USB in here to charge it up. So that's what I'm going to be working on next few days. Unfortunately, I'm one of those darn required workers, so I'm still working 40 hours a week, so it's kind of limiting how much I can work down here on my workbench. So yeah, that's what I'm working on. So yeah, I should be able to pack in 3 of these big cells. Tomorrow night I'll probably crack open the Nomad. This to show you looks, well, maybe I got a little time. Maybe I'll take a look at the Nomad right now. Put this aside. Nomad was he's a portly fellow. He's a very thick system because I had to take the entire standard Sega Genesis cartridge in there. So kind of cool though. I wish one of these I'll probably end up buying one for myself and modifying it. That's the irony. I fix retro systems. I don't actually have all that many of them, so I'll go through and might buy one of these eventually. I'm not sure. So yeah, it takes the standard Sega Genesis. Kind of neat. Has a second controller output. So if you wanted to play 2-player, you can plug it into a TV. One player uses this as a controller. You got a nice 6-button controller going on here. And then you can have someone else with a standard Genesis controller elsewhere. And this actually had audio and video coming out. So you can just plug it in TV, use it like a console. So kind of a neat one. Biggest problem, battery life. 2 problems, battery life and the screen. Oh, other than the GameCom, I think it's probably the worst screen of any of this, just by any system. Game Gear has a really bad screen too. The Nomad, for such a powerful machine, they put just an awful passive matrix screen that blurs like crazy. But I'll do a side-by-side because I'll have the screen and I'll have the new screen next to it real time, and you can see what a huge difference it is between the old and the new. Let's see. I'll show you what the inside of a Nomad looks like. Can't remember if they have an anti-tamper in one of these. They probably do. I think this one's an anti-tamper. The Game Gear had the same similar anti-tamper. It sat right up here under the right by the where the cartridge slotted in. Yep, anti-tamper down there. If I wanted to see it, there it is. Hiding down the hole. There's your anti-tamper. It's your anti-tamper bit. So I don't mess up the plastic too bad on here. I actually need a better anti-tamper bit one of these days, because on the Game Gear it works fine, but on the Nomad I actually can't quite hit it. Do I have another one? Let's see. That one's too on the small side. I have quite a few anti-tamper bits. But I'm just questioning if I can. Yeah, see. I'm gonna have to rammer jammer it down in there. Sadly, sorry. Usually I end up scuffing that surface a little bit just to get at it. No harm, no foul. These are these little annoying little bits, the screws they used. Alright, so this is the inside of a Nomad. So kind of a neat little system. It's a complete Sega Genesis, really. The actual internal code name was Venus. You know, you had the Sega Saturn. There's also going to be Sega Neptune. It never was released. It was the successor to it. But this actually was called Venus, was its internal name. So you have your screen, which used a little fluorescent backlight here, which is kind of cool, and it has a neat sheet that comes along here that reflects back into it. And you can see is IC Venus. So this board contains all the drivers for the LCD screen, and then the other side, these little connectors, you pry it open like this, and you pull it straight down, and it comes out. So you can see here, this is your this has all the drivers for it. Pull these screws out and pull this out later. But this is, you got your volume control over here, amplifier volume control, and over here you have your brightness control. And this is just this subboard here. I always wonder why they only put one screw. I've noticed this before. Oh no, that's because it hits here. This is just holds the start and mode button here. This mostly is on the other side, and when I take it off, you'll just see it's just a bunch of it's just the pads for the controls. Most of the brains are actually on under here. So we can mess with that later. You can see the engineering behind it. Like, this is where your D-pad would press, so it's installed underneath, and this is where your 6 button controls are. So when you have force going through it, it hits this rigid plastic instead of flexing the PC board itself. So the PC board's here, but it has the support underneath, so it's not putting constant flexing force on that PC board. So pretty decent engineering overall. Well, since I'm here, I can show you. Let's take a look. Lots of little screws. These old consoles, with the exception of the Lynx and the Game Boy, which are ironically the older consoles, portables, had very few screws. Like a Lynx 1 only has like, I think only had like 6 screws internally, and I mean in total it was pretty amazing. And the Lynx 2 is very similar. Game Boy only has, I think, 5 screws. Nintendo uses little tri-wing screws for theirs. Neat upgrade I've done on that, on the Game Boy Advance, not the flippy one, but the old AGS. I've modified it so you can actually put the nice backlit screen in there, and it makes a world of difference. Wow, these screws are not behaving today. Get in there. I'm going to pull this up, and actually probably can leave that. Let's pull that. Yep. Feeling that's attached to the screen, I'll leave that. And this guy over here. Those wires there for the speaker. I think. I can't remember. Maybe it's the high power. Let's see when I flip it over. I think these are the speaker. This is the speaker. Can't remember. See when we flip it over. Try to get those out. I do like when they use this a single size screw for everything. It makes it a lot easier when you're putting everything back together again, instead of having to hunt. The worst offender I've ever seen by far is the Tiger Gamecom. It has like 8 different sizes screws, and I think close to 35 screws, which is just insane. Yeah, that did it. the speaker. Pull the speakers off. Okay. This is interesting. Then I'll show you. Alright. So this is the, it's just your standard membrane. This is conductive carbon pads. Identical to technology to what they use now. There's nothing new about it. Or it's still current tech speaker. And the push buttons, and the buttons. I'm just going to leave this. I'm not going to mess with it. And that can go. See, almost everyone I've seen has had a cracked. Right there, there's been a crack in the little bit of rubber they use. I don't know why. Put that with the rest of the parts. So this board, you can see there's actually not a lot to it. There's just, these are your pads for your, this black is conductive carbon. These are your pads. And then there's the screen that's going to go away. And before I take out the screen, I'm going to add the new one. So new screen's actually pretty simple. You come in over here on these pads. I can't remember which test points it is. I'll get my notes out before I actually dive into this. So this new screen actually ties into here, and then over on this side there's a 5 or 12 volt line. I'll tap into over here for the power for it. So yeah, that's what's going to happen. So I'm going to go through and start. Probably replace some of the caps, particularly on the big ones, and then start replacing the screen. So that's enough for tonight. Getting a little tired. Worked a full day today, and I'll go through and show you what goes on under here. Till probably tomorrow. Talk to you all then. Bye bye. Okay, for tonight, I really wanted to show, with this Nomad, what a difference the screen makes to it. This is the original screen running here, and you can see this is the replacement screen running in parallel with it. It's a night and day difference. It's even worse in real life than it is in the video. You see in the modern LCD, the blacks are actually almost completely black on the, see if I can adjust the Nomad screen to look kind of how it looks in real life here. This is, I mean, no pun intended, it's a night and day difference between the two of them. Because in order to get this look halfway decent in the video, I have to crank up the contrast, and it looks awful in real life. I mean, the dark areas are light gray. You can't even tell this is even blue on here, and it's just, I've always been a bit surprised at the poor quality screen they originally had installed on the Nomad, and there's a lot of motion blur. The contrast is truly awful. The colors are awful, and there's not really a great excuse for it, because the Game Gear suffers similar issues. But I mean, at the time, the Atari Lynx was released in '89, and the Lynx 2 was released in '90, and they both had much better screens. So, though I did notice one interesting thing. There's a slight delay between the composite out, or maybe it's the other way around. I'm not sure which one's faster. I believe the internal screen actually lags the the external screen just a little bit. So it might actually be a little bit easier to play just from a response time on the built-in screen. So whatever DSP is running in here is faster than the DSP that was driving this. Yeah, you can see this is flashing before that one is. So the DSP on here is actually a little bit faster than the one built in. So DSP is just digital signal processing. It's just taking the analog signal and processing it. So it's that's where I'm at right now. So what I'm going to do is, well, unfortunately disconnect what I just did. Route the cabling a little better, and I need to go through and replace a couple jacks on here, like a power jack I want to replace, and I got to flip the board over and just start doing some cap replacements, and then that'll be it. Still waiting on the batteries, still waiting on the charging circuit, so this COVID is killing me in terms of timing. I mean, parts I ordered over a week ago still aren't here, and they were supposed to be here already. But anyway, but yeah, you can see side by side what a huge difference there is in the screen response and color. If you ever have any hesitation about getting your Nomad screen replaced, get it replaced. It's well worth it. It'll be like a whole new system to you. Okay, so welcome back to my workbench. I did get in these nice lithium-ion cells with a terrible name of Ultra Fire. Go figure. It's ironic because if you cut open a lithium-ion cell, they will catch on fire, so not good. But not too much Chinglish on here. There's a little bit of sheaf life around, which is ironic, but should last about 10 years or more, so that'll go for a while. Turn off this one light. For some reason I have one LED light that seems to really flare up on the video, but the fluorescents are okay. So I'm going to go now is, like I said last time, I'm going to actually take off that was scary. Take off the cabling I just did. I ended up hooking into the battery 9-volt line, so it's not a huge deal. Let's come off the ground. So get this out of the way for now. You know that it works. Now go back, flip it over. You see this type of connector here. This type of connector here, you just pull it forward and it pops right out. So, let's start doing some cap replacements, I guess. What we could do first is, we have this one cap on the front. It's a, it's like a 10-100. I always forget what that one is. Let's see what's in the box. Alright, so let's see what we got in here. This is 125. This is an 820, 6.3. And the only other one they have here is a 116 volt. So this is probably a 110 volt axial lead. Pop that sucker off real quick. No, that's really on there. Wow. Kind of in shadow here. Only thing I always want to avoid doing is floating the when you have surface mount components, you want to turn down the heat on your iron a bit, just so you don't accidentally go through and what they call it floating off other components. What I'm going to do for now is just do it a simple way. Just going to clip it. They used a little bit of adhesive to keep it from moving around. Take those leads off. Lots of times you can just use the surface tension off of the solder itself to pull the components off the board. So I'm just going to bend this down. Replacing capacitors can be kind of relaxing because you're just going through the motions of clipping leads and getting in there. I don't think it's going anywhere. So, got that cap replaced. And the fun one is going to be, first thing I want to do is replace the power jack. It's in decent shape, but since I have them anyway. So before I go any further, you can see this is the original battery pack and the new lithium-ion cells will fit in there pretty well. I'm just going to have to cut off a little bit of the plastic here, but that's actually really easy to do. Also, what I'm going to do is trim off plastic here because the rechargeable circuit board, the board for controlling the charging circuit is about this big. And it'll fit right in here. Yeah, it'll fit right in this area here. I'm going to use the existing, it's hard to see, I'm going to use the existing slot there to go ahead and the USB will easily fit in that slot. So I'll have a micro USB sitting right there, and we can go ahead and looks like I can pretty easily fit 3 into the existing casing with just a little bit of modification. So these are beasts. These are 9,800 milliamp hours, so it's a lot of watt hours coming off each one. So each of these cells should actually run the Nomad about 10 hours, so might get up to about 30 hours on one charge. The only problem is going to be it's going to take about 10 hours to completely charge the pack, but who cares? If you have two packs, it takes 10 hours to charge, it won't matter because you'll have 30 hours of runtime to play with. Alright, let's see if we can get in here. Get this. This is the power for the backlight. There's actually a couple big caps here. I'm not going to bother replacing because they're just the caps for the high voltage for the, not the high voltage, but it's just the voltage for the screen. I'll probably end up replacing as many as I can, but some are slightly pointless. We're not going to see much power ever again. Turn my iron up a little bit. Yeah, the only thing when you work with old boards, you don't want to overheat them, because you can end up in a situation where you float off a component, or you end up you either float a surface mount off the board and you have to go in and place it back, tack it back into place, or you can actually damage the pads. You don't want to damage the solder pads. You do need to apply a bit of heat though on the on pads that are particularly on a ground plane, because there's just physically a fair amount of mass of copper on the board. It'll take a while to heat it up. My biggest worry here is when they put these in, they put a little twist on it. Let's see if I can heat this up. Yeah, it's better. Yeah, my only worry is they put a little bit of a twist on the sided tabs, so it makes it a little more challenging to get them out. This screen here, I'm not worried about getting spit and garbage and solder on there, because I'm just gonna, the screen's all gonna be basically thrown out anyway, so it won't matter. So I gotta straighten these up, or I'm not gonna get them back out the holes. Let's see if this comes out or not. Rock it off a little bit. Yeah, still a little stuck in there. Too bad. These are my favorite needle nose pliers. Exceltra. Made in Pakistan. But I like them because they have a spring that automatically opens them up. These do too. But these are a smooth jaw needle nose, as opposed to having the knurling on the inside. One side's free. Other side. Just kind of trying to break the solder joint on there. What's left of it. Again, I'm not terribly worried about damaging the jack itself, because it's getting, well, ripped off the board right as we speak. Screen I'm not too worried about, because I know the new screen works. You can see this is rocking in here a little bit. problem I run into is this is the jack here, trying to get those solder joints to move. It's moving pretty freely. Two of them are. Since we're in the middle of coronavirus, I'm sure this is viewing gold right now. Compared to like watching Tiger King or something like that. That's a crazy series if you haven't seen it yet. Just my biggest disappointment is the fact that no one really brought up the point that, like, keeping these animals in any kind of captivity kind of sucks. I mean, even in real zoos, you can argue it's not a great life for a tiger or lion. Or the worst abomination, they make these ligers, which are a crossbreed, which are more or less mules. They can't reproduce, and they have no place in the wild, so they can only exist in zoos. You can never release them because there's no such thing as a liger, which is just wrong in my opinion. I don't know why they allow those zoos, those private zoos in some states. It's just, unless you're doing conservation work, you really shouldn't be doing that. I like conservation zoos, ones that actually make a difference. Something like around me, there's Brookfield Zoo. It's a conservation zoo, so they have a lot of endangered animals there. So that's the fun one there. So, jack's replaced. Let's see. How many pins of fun do we have for this one? So this one, the replacement jack's slightly different because it doesn't have the rear tabs, but it doesn't really matter. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9, 10, 11. In case you ever wonder why you have to pay so much for a completely repaired Nomad, as you can see how long it actually takes to go through and replace jacks and capacitors and all that fun stuff. So you are getting your money's worth. It's not I don't get rich off of any Sega products. Segas are my really low margin products of all things, because they're just they're a lot of work. There's a lot of caps to replace. Even on a system like this, there's a ton of caps to replace. A lot of caps to replace. A lot of surface mount to deal with, like a Game Gear with the McWill screen mod. It's a lot of work to do. I mean, it's wonderful when it's done, but oh my goodness, it's a ton of work. I like doing it. It's relaxing. But if I had to actually make a profit off of it, I don't think I would stay in the business very long. Sega stuff I break even on. I don't make any money on Sega stuff. Atari stuff, oh, that's a different matter. Ataris are awesome to work on. Simple systems. A lot of them only have one cap on the entire board. I don't... my claim to fame is I have my Atari Jaguar to 5200 controller converter. That one's a fun one. That one is something I figured out, and it works out really nice. I think I've sold about 20 of them. Those are fun. Those actually are interesting. Sitting here popping caps off and connectors off is a little on the tedious side. Though I've heard from more than one patron of mine, not a lot of people still do it, which is surprising. I mean, you're not going to get rich off of it, but you do end up getting a somewhat steady stream of work. There's enough people out there still collecting, needing their systems repaired. I mean, if you're good with an iron, I would recommend learning how to recap these old systems. Sometimes I'm reminded way back in college, it was over 20 years ago now. I graduated in 98, so that was 22 years ago. But it was way back in freshman year, so I guess that was over 25 years ago. Had a whole couple weeks of just how to solder and desolder and fun stuff like that. Some people love solder wick. I never got into it. I've always been a solder sucker kind of person. See, these pads are actually attached to the outer metal shield, so they'll take a lot of heat to get that solder to really flow. Now, the brown stuff you see on the board is not actually like burn or anything. That's from the flux coming off the solder. The old solder that's actually on the board. There's flux on the board still. There's no conformal on here, but there is still flux when they did the put the board through the reflow oven. So you actually see it come out a lovely brown. Looks like all the big ones I got except for one pin I'm not happy with. I'll probably end up clipping the shield leads. That'll make it easier for me to pull it. See if I can look at this under the scope. And still not all that happy with that one end one there. By TP 244 there and 241, I'm not happy with that. It looks a little bit attached. That's not too bad. One of the first things I had to learn when soldering was if you drop your iron, let it go, man. Let it hit the ground. Don't try to catch it. You have to overcome that instinct to catch falling objects because you're just going to burn yourself. I'm a little concerned this LED here didn't have any kind of brightness at all. I'm going to play with that later before this is all done. Yeah, I'm just going to go through here and clip these legs if I can get in there. Clip the legs, and then I'm going to go and just desolder them as legs, not as this whole mass here. It's going to take forever to get through. See, this is all shielding, and it's too much for my iron to actually get through. Wow, I've been doing this for 25 minutes. Holy moly. Okay. Let's see if we get that cleared out or not. If you get experienced at soldering and desoldering, you can actually watch the solder reflow. This is not wanting to come off very easily. Again, I'm not really caring much about this screen. It's going to be in recycling bin probably tomorrow. These old systems had the most over-the-top shielding for the time. The FCC rules have changed. Since then. Oh, these old things had so much shielding. It's not even funny. I'm not going to sit here and have everyone watch for the next 20 minutes, me getting this connector off. So I'll jump back once I got it off and maybe do some caps. Okay everyone, welcome back to my workbench. After a little bit of finagling, I finally got this connector taken out, and this is the new AV out connector on the board. The brown stuff on there is from, let's see if I can blow that up. The brown stuff on there looks scary, but it's actually just, it's flux from the solder I was using. I'll probably end up cleaning it off later so it looks nicer. All I gotta do now is solder it in. This new one only has tabs up here, which is interesting. It has 3 support tabs. So it's 1, 2. Sure, get enough heat on that one. 3, 5. gotta apply a bit of heat, just so, because it's connected to a large, basically heat sink. But these guys here are real quick. Doesn't take much solder at all. So a little more of that one. Preferably when I get all three coming in, you want the heat, material you're soldering to, and the solder all at the same time. You don't want to sit there with the iron on the pad, just heating it up for no reason without solder there, and you won't get good heat transfer anyway. It's on that test pad, it doesn't matter. I'm also trying out some new lighting in here. So I got two big umbrella lights going, and I'm also trying out to do a lavalier microphone, which is on my shirt collar right now. So this should be interesting. Let's kind of cover these up like so, just to make it look nice, because they're not actually connected to anything right now. Okay, and that takes care of that. I'll come through later with some flux cleaner and clean that off when I'm done some other work on here. I already replaced this capacitor here. No, we'll scratch the screen. Oh well. It doesn't matter. It's gonna end up in the trash bin anyway. Alright. Let's see how hard it is to pluck these off. 100. What do we have here? 47. 10. 20. This is exciting watching, isn't it? Oh, in case you never noticed, that you'll see I probably wear a different watch every day. That's my other hobby, is watch collecting. Today I'm wearing the Casio digital. This one is, I like this one because it has a better luminescent backlight on it. The classic one is the 92 or 91W, I should say, and that one is not so great. See, 100. 1, 2, 3, 4. There's your 220 sitting over there. A bunch of 47s. Ah, yes, Sega, and your love of capacitors. I got 6.3 volt 820. What a big boy. Did I get one in this kit? Usually they give you a big 1,000 microfarad in there just to compensate for it. You can always usually go up a little bit on the capacitance. You try not to go up too much farad wise, because you don't want to change the dynamics of the circuit, because there's something called an RC time constant, which, so if you change your C too much, you change the time constant of the circuit. I don't think I'm actually using that one much anymore, so I'm going to leave it. Okay, 100. Let's see how hard it is to take that out. It's actually been a little while since I've done a recap on one of these. Usually, can just pop one end off. Come on, baby. Unfortunately, how these are made originally is they go through they get pasted to the board, and they go through what's called a reflow oven. So that's how they make it. So the reflow oven actually kind of looks like a large toaster oven, of all things. Oh, it's coming right up. Come on, you can come. Let's see. Nice big pad underneath. That's nice. Yeah, they have a nice big solder pad underneath. So, see how nice? I'll show you what it looks like. There's the old cap, and you can see right there, this is where the old capacitor used to be. They have these nice, really big, shiny pads there, which is nice. It's easy for me to work with. And here's the new one. The new one. Yes, you just want to observe the polarity and the value. This is a 10. I need to put 100 in there. 100 came out. See, it says on there. 100. That's 100. The black stripe is the negative on these little surface mount caps here. Where's my 100s at? These came on what's called a tape and reel. In a pick and place machine, there'd actually be a pair of pincers that come down through this plastic here. Actually, they peel it back too, and what happens is you actually see these little spots here. And the machine, the pick and place machine, actually really cool if you've never seen one. Pick and place machine will grab the component and place on the board, and usually there's what's known as optical fiducials on there, which will tell the pick and place machine there's reference points on the board. Like in this case, they almost certainly use the screw holes as fiducials, so they can when they put it into the pick and place machine, the camera that looks where you need to place the components will look for those fiducial marks to line up the machine. There's no crosshairs on here, so there's no fiducials. But you can see they put pluses everywhere in case a person needs to rework it, or sometimes they even have the camera system check to make sure the polarity is correct before you put the caps in. It's a really clean board here. This is 100 stripe. You can see the positive there, and then you can't see it. There's your positive, the little plus right there. So don't hook up the caps backwards, because what happens is they turn into little ugly party favors and pop. Hydrogen will form, and the capacitor will explode. Well, it won't explode, it'll pop. I remember my instructor in college, like our first engineering class, he was like, if you ever hook up an electrolytic capacitor backwards and explode it on purpose, he would get you expelled just for that. Because he was blind in his left eye from a exploded electrolytic capacitor. So he did not mess around. What was his name? So I always went on about how he knew electronics was, you can have a Thevenin or Norton equivalent circuit, and his was, it's like he knew Norton, the actual engineer it was named after, which is actually kind of cool. Make sure you have a good flow on that. Wow, that gets hot. Okay. I'll do it with my hand. Remember my first engineering job, the rule was a good Electrical connection begins with a good mechanical connection. So it's a tiny bit proud of the board, but I think it'll be okay. I mean, it's not much different than the machine placed ones, because they actually have a little bit of a dab of adhesive on there. If I was feeling really bored, I'd go through and put little dabs of adhesive on the back, but I'm not using that much time on here. I don't think anyone was going to want to watch me place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 capacitors. That would not be very entertaining watching. So, when we jump back next time, I will go and have the caps replaced on here and do a final check on the screen. And then once that's done, I will remove the old screen and just have the new screen in place. And then after that, I'm going to have, I have been working on the battery pack, wherever the heck that went off to. I have, working with the parts I have, I'm still waiting on the charge circuit. So I bound together these, well, soldered together and bound together these 3 rather beefy ultra-fire lithium-ion cells. So they're all bound together. Nothing went pop when I did it. I had to do a bit of flux, especially on the back side, to get them to stick. The front wasn't so bad because it's pretty thin, but still getting 3.7 volts out of it. Actually getting about 3.8 something off of full. These are fully charged. Bound them together with Kapton tape and did a tiny bit of modification to the battery holder so far. So it's going to sit in here like so. And then the charging board will sit right around here. It's about this big. It'll sit right there. And it'll be kind of up towards this side. Where's this thing? There it is. So you can see, took out the old board and the electrical contacts came out and marked on there, so I know which one's which. And it's pretty close to fitting already. It's not going to take too much. And I have a little, I have an XY slide in a end mill, so I can slice down the plastic a little bit. You can see even now it's pretty darn close to fitting back together again. Once it's all put back together, you won't notice the jagged plastic quite as much, but I'll buff that a little bit before I'm done. But the only thing I'm going to have to remove is, let's see if we get the light properly. It's hard to see, but this, wow, this is really hard, the video. There's a plastic tab sitting here. Microscope better. Wow, it's blackness. Huh. Well, that's useless. Okay. Well, trust me, there's some plastic tabs there. I'll probably have to take some pictures with my 35mm, not my 35, my DSLR, to get a good shot of this, because it's not showing up very well on the webcam at all, which is unfortunate. But there's a section here I'm going to mill down here, and just this part of this battery tab here, and there's 2 tabs sitting here, and then there's a little bit here that needs to be sliced off, but not too much. The end mill will take care of that in a minute or two. Just come across and just zing it off flat, and that should be enough space for it, because these batteries are actually a touch thinner than the existing cells, so that worked out really well. I just had to take a little tabs off here, but that's it for tonight. Well, for the video, because it's too boring, and I'm going to keep working on cap replacements, and that should take me an hour or so to replace all these caps, and then off to the screen. So the next time we jump back, it'll be on the screen installation and removal. Talk to you later. Bye. Okay, so this is another What's on My Workbench. This time around I did finish off forgot to grab it. I did finish off one of the battery packs for the Sega Nomad. So now it has a little USB charging port on the back here. It should last over 20 hours, if my math is right. You can see it's running off the battery pack now. So it's running completely off the batteries. The weight is decent. It's actually a little bit lighter, but not terribly lighter than the existing pack, so the balance isn't way off. So, since I got one pack done, I was going to show how I did it. This way. So this is the pack itself. Only problem I had last time is I scuffed up the sides a little bit, so I'm going to try a little bit different this time, using a different spudging tool to get in there. So far, I mean, you have your little, these are your lithium-ion cells. This is the little charging circuit that's going inside. This is the existing pack. Let me see if I can. So it looks like these packs are just glued together, more or less. So you kind of have to get in there and break the glue holding it together. This is tools actually left over from, I think it was a Motorola Razor years ago that, yeah, it's hard to get these cases open. Yeah, I'll leave that one in. Leave one in the corner. The last time I opened the cases up, this battery case up, I used a metal tool. I left a little too many marks on it than I liked. Come on, you can come. Key is you don't want to undo your work as you get in there. Let's see if we can get in here. A bit more force than you'd expect. There we go. So you get the spudging tool underneath this lip. You can see the lip actually goes this way. You can see there's actually a little glue bond on here that actually holds it together. So when you open one of these up, there's not too much to it. You have, these are the now leaked cells. So all we're going to save out of here is don't need any of this. I am going to save this board here just for aesthetic reasons. I like to leave this in just so it looks nice. But in terms of actually doing something, it doesn't do anything. If you plug it in, it won't go anywhere. So all I do is clip everything. That's garbage. So that's a piece of garbage. Alright, so when you actually get in here, what you're going to have to do is, I'll reset up my camera on my other workbench. I have two workbenches. These parts here need to be milled out, because otherwise when you go to put it in place, see how it sits a little crooked? What you do is I'm going to mill this out, and mill these out, mill this surface down, and mill these fins off, and then the actual board here is going to go in just like this. So I need to mill off these two fins here, and mill the whole top surface here, and mill these off, and mill this off, and then I use the end mill to cut a oval slot here. This board will sit just like that. So it'll sit in there just like that. With I start the mill hole here and move over, so it's gonna sit just like that when it's all done. Batteries, later I'll show how you actually can safely attach wires to these batteries and how to attach it, and go through that later. But I wanted to just show how you open it up. It just takes a couple of these little tools, these little spudging tools. They get in there. The glue bond, this is the back, this is the front. This part's the back. Zoom back out. So this is the back, this is the front. You can see when you come in, you gotta come in going this way to pry it off. So you come along and you break the glue seals that are all on the bottom case. You can still see there's glue left here. But yeah, that's how you pry it apart. So that's step one, and then I'll get my camera set up on my my other workbench, and I'll show you how you actually go through and mill all these off. Alright everyone, welcome to my other workbench. I actually have two workbenches. One of them is for mostly electronics, and the other is for mechanical work in terms of cutting plastic. I have this, let's zoom back a little bit. Ooh. This lovely Dremel tool here with the stand, which I can raise up and down, and a nice little XY table. I can easily control where I want the parts to go. So we're back to the Sega Nomad battery compartment, and it's positive, it's negative. So the material I'm going to do is I'm going to take down this entire surface here. I'm going to take these off, these little fins. I'm going to cut a little channel here. I'm going to cut this section here on this one. This surface doesn't matter because where the batteries hit, it doesn't really get to. And then similarly on the bottom case, the top half, I'm going to take off this material, these edges here. Probably take a little bit of this off too. Actually, these don't matter up here. Don't need to worry about those. But I do want to take off this, and a little bit of this. So I could come through with a pair of nippers and do the same thing, but I just like the way it looks when you give a nice clean edge using the end mill. End mill is just a special type of drill bit, really. It has little fluted edges that allow you to move it up a little bit so you can get at it. Sometimes you gotta take these off and move them a little bit. Let's see if we can get with this. This would be good enough grip with this. Key is you don't want to go too nutty with it, because you don't want to completely destroy it. It's actually a stop over on the right side of this tool, so move it out a little bit. Hit the stop, come back a little bit. Usually I eyeball it anyway when I'm running, but in case I get too enthusiastic, I can control, make sure the depth isn't too high. Actually, it's really cool how this works. You just turn around. I actually need to move this forward a little bit so I can get at it with the working with the end mill. Loosen up. Let's move it up. Now, if you're ever working with these end mills, don't touch that bit. It is really hot right now. Hotter than you'd think it would be. So that was the main pass I did there. Move this up again. These come off. Come on. Get back here. originally got this end mill, this whole setup here with the XY table for modding a Game Boy to put a different screen in there. But that was quite the challenge, actually. That was actually kind of unpleasant. Don't really want to do that one again. See, the problem I run into is I hit the... Check depth here. So again, I'm using this little, there's a little limit on the side here. I like to set so I don't accidentally bore through the bottom of the world. This one isn't really easy to get much taken off. Two of them. Here's the third. The longest part is repositioning the hold downs. Someday I'll get a table with more travel, but the amount of actual plastic cutting I have to do really doesn't justify it much anymore. I probably will end up using this for one of my own projects. I'm going to take an old Tiger Gamecom and install a Raspberry Pi in there with a new screen. The biggest limit I'm thinking there is I might need to cut a nice cutout in the back of it just for the depth, but I might not have to. I'm not sure yet. So that's a wacky wild project coming. Now I'm also going to use this setup for making like a my own version of a Switch with a nice 7-inch display, but arcade style control, so that should be interesting. I saw it move, so I stopped it. Well, I think the key to doing any quality work is even if no one's ever going to see it again, you know you did it right. You don't want to know there's some hokiness going on in there. Again, I left these tabs, it didn't matter, so these are all taken off now. I'll come through with a pair of... this is my thumb. So those are all zinged off now. Now on the other side here we have, this is the back. There's two things that need to go on here. Take this out, take that out, drop that surface, drop that surface, drop this surface down, and cut a hole for the USB charging port. Take these out. These will get reused because this is what makes the contacts that actually interface with the Game Gear. Well, it's convenient. I'll use the other part as a tool holder. There we go. Alright. More noise. It doesn't need to be. I mean, I try to keep it pretty straight to make it easy to work with. The only one I'm really concerned about how straight it is going to be the hole for the USB charging port. Okay, so we're getting there. Okay, get over here. It's actually the very first time I've ever taken video of my plastic cutting. Stage anxiety. Yeah, that's actually turned out pretty well. I'm going to have to come back and clean that up a little bit. Now, for now, it's actually getting pretty late. I'm getting a little tired and a little slap happy, so I don't really want to mess this up tonight. So I'll be finishing this off tomorrow, so I'll end the video tonight. I'm not going to cut anymore tonight because I'm just a little tired. So I'm going to finish cutting this down, this down, and this down. I'll do that tomorrow night and do the batteries, so we can see how it works.
Okay,
I will
I'm
talk to
taking like
everyone
a 10-minute break from my day job, so I can do a little bit of what's on my workbench. Maybe I can knock out this plastic cutting. I hope this hasn't been too annoying for everyone. But let's go anyway.
was annoying. Okay.
The big thing is for the last, oh my goodness, must have been at least 7 weeks now. Been working from home. Starting to drive me a little nuts. Let's see. That's better. Okay. Who knows? Maybe I'll time lapse and montage this one. I'm not sure. Okay, so that's the last cut. Well, not the last cut. I have one more cut after this, which is going to be the battery hole. Doing a little cleanup work with the file. I'm gonna freehand one of these. gotta check and make sure I can close the batteries up. Get in there. Oh yeah. Closes up real nice. Too nice, actually. Can't get it apart. Yeah. Alright, so the last of the plastic cutting will be just a minute. So the battery compartment hole, I'm sorry, the charging port hole will be right above the Sega on the label. This is the last plastic cut. Yes, that is smoke you see when you do this. The plastic melts a little bit. Let's see. Yeah, that'll do it. Plastic slot. That's where the charger is going to go in. So a little bit of cleanup work on the back I want to take care of. Let's see, I'll just freehand it. The unfortunate side effect of having to do a high-speed mill like this is the plastic does melt, and sometimes you'll get pieces that come off actually reattach. Might want to make that slot a little longer. A little higher, a little longer. So I lied. Sorry. Get you nice and straight. Hit that with a ROM file in a minute. Yeah, that fits better. So yeah, there's the little guy goes in there. So you have to see why it's not sitting all the way flush, but I'll work on that a little bit. That's enough for now. Okay, we're back on the electronics workbench, and we're entering the home stretch here. So we have the 3 cells, the battery charging circuit, and the enclosure with everything cut out that needs to be cut out and actually get it together. So first off, I'll do is put gang these together. I'm running them in parallel with each other, because the charging circuit here is expecting a 3.7 volt lithium-ion cell, or lithium polymer cell, same difference. So I have this nice, pretty decent length wire here. What you do is you want to scuff up the surface a little bit. And then take a little solder flux. I don't usually use flux, but for surfaces which aren't really meant to take solder initially, I like to throw a little flux on there. Man, that's some old school solder flux. That's Radio Shack there. Can't remember when I even bought that. So I'm just gonna strip this back. Yeah, about so. Give it a little twist. I'm going to apply some solder to it first. I still use tin lead solder. I just find that's what I learned on. I use 60/40 tin lead. Probably not the most ecologically friendly, but on the other hand, I don't get tin whiskers or anything like that. This particular iron, I like this iron. I just switched this one after discovering a problem with my old iron. My old iron had a hard connection to ground and caused issues when you're working on live circuits. This one's nice because it has the temperature on there, so I get to set the 650F right now. Well, get some flux on my table, it's alright. Put some more on in a minute. Kind of just want to hold it together, so see if I can get some flux to flow. Actually, I have to be careful on my table because it is a static table. It's ESD, so it actually conducts, so I have to be careful. Let's see. Get some solder on the back of this. Yeah, my table actually is conductive, so you gotta be careful. See, even with the flux on there, it doesn't want to flow much. See how it just made a bubble there. There we go. All right. Strip it back a little further. I actually encountered this problem with my last set of cells I had to hook up on here. I just didn't want to really tape to solder. Come on. Not the best soldering technique here, but it will get the job done. Surface just won't wet. That's what, see, comes right up. Snug it in.
So I'm bumping the soldering iron up to about 75 degrees, see if that helps. You know, I've been doing this for 20 years and I still occasionally get one that just doesn't want to solder. I don't want to think about how much solder rosin I've inhaled in my life. That did the trick. It needed more heat. Perfect. There we go. Yes, the iron just wasn't hot enough. My wife told me my English skills have degraded a little bit during this pandemic. Which is, I thought was kind of interesting. I can hear some bizarre reason I'm getting a slight southern twang, which makes absolutely no sense because I was born and raised in Chicago. 5 generations before me too, so I don't quite get what's going on. Or it's just part of the madness of COVID, one or the other. Really? It's really just the back side, this negative side, that's the problem. The positive is a lot less thermal mass to deal with, so it actually solders up pretty easily. I personally prefer when I clean my iron to use this metal stuff. It's like I think it's brass to clean my tip, because if you use a sponge with water, I think it tends to dry it out a bit. I mean, not dry it if it cools off the tip too much. Let's see. Good. I'm cutting out a little short there, but if it doesn't work, I will go ahead and just lengthen that wire. You know, it's a little short, but I'll make it work. Alright, so then we have the positive side. not to get too schmaltzy about everything, but I really do appreciate still getting new orders and mods coming in, even in the middle of a pandemic. I mean, it's slowed down a bit, but still getting orders, which has been really kind of nice. And it really is, working on these things actually helps me mentally during these weird times. I'm kind of humbled by all the trust and faith everyone has in me. Time of these mega corporations, it's still good to know that tiny little businesses can still operate. Of course, try to go to Amazon or something like that, you'll never get somebody doing mod work like this. This is real kind of specialty work nowadays. Not that I don't really enjoy it. If you're not going to do it for the love of it, don't do it at all. I do it because it's a change of pace from what I do during the day. Testing stuff and test reports and things like that. A lot of computer work. It's nice doing hardware every now and then. Okay. So that's the pack. I wish this wasn't so short. I might have to make that longer. Alright. Let's see how it's gonna fit. It sits in here like that. Battery lead. I think we'll be alright. The battery lead's going to go right there. So in this little guy, there's a positive and negative battery lead, and then there's a positive and negative voltage output. So I'll do the battery. I like to hook up last because it is live. It is a live battery. Let's see. Here's the old tabs. So here's the old wiring that came off the battery housing. Let's see if we can get that off. How did they wrap it? The only problem with stranded wire, it tends to come out as like a big glop. It separates as you're trying to take it out. If it's solid wire, you can just pop it right out. Oh well. Because of the colors I have, I'm going to go with, they use green for negative and orange for positive, but I have a white wire, so I'm just going to use that up. goes in like this, so I want to come out this way. The nice thing is if you have a soldering iron, it does have variable temperature. You can turn it down when you're working on older boards, because what can happen is you'll overheat the board and it'll delaminate and make you sad. So where's the green one? There you are. They used green before. And then it came out that way too. See if we can get this one out without. There we go. Green wire. Rub through the same way. Go. Green goes at the bottom here. It's spring loaded, but not overly so. So it's easy to snap off the battery pack. But that's how Sega designed it, which was neat. The permanent, the one you use disposable batteries on, actually is a little bit difficult to get off because they use like a piece of spring steel instead of these little posts. Okay, so this is battery outputs. No, sorry, the voltage outputs. Let's go with, it's coming up like this. And since the circuit's not powered right now, it's not something really you gotta worry about anything blowing up, because I don't have any battery hooked up to it right now. V out negative is on the left. V out's on the left. So that's green. Strip all of that off. Don't need much. Negative is on the left here. I'm going to be mindful of which direction these wires are coming out. So I want it coming up this way. So if I went this way, that's down into the plastic, and I don't want to do that. And I'm soldering them flush to the board because I want to get as close as possible on the back side. Okay, now we have the battery out. battery in, I guess. So negatives over here. I shouldn't have cut those so short. Oh well. Finally, battery plus. Okay, no smoke yet. It's a good sign. A couple quick things, and we're gonna close it up. Let's see. What we need to do is check and make sure the charging circuit works. It just uses a regular micro cable. This is quite meta. We're charging a battery pack with a battery pack. Little red light comes on here, and when it's fully charged it turns green. You're not going to see it on the inside, unfortunately, but just throw it on charge overnight and you'll be fine. Charging circuit prevents it from overcharging. And now, last thing I'm going to do is set the voltage. In the factory, it's usually, right around 6 volts. It's very consistent. They're always about 6 volts coming from the factory. And there's a little adjustment potentiometer on here. We just turn it up. Nomad wants 9 volts. Usually give it right around 9.2. Won't hurt it at all. And that's it. Now all I gotta do now is just attach this to where it needs to go. And where's my good tape at? Well, there's a good question there. Here it is. This is extreme mounting tape from 3M. Our friends at Minnesota Machining and Mining. In case you ever wonder what 3M stands for.
And I lost my scissors, which makes me sad. Okay. Yeah, well, use a cutter instead. From what I can tell, this stuff is not conductive. There's not much in the back of the board anyway. Actually, I should test that. Good. No continuity, so it's an insulator. This is technically a pressure-sensitive adhesive, so the longer and harder you press it on there, the stronger the bond will get. So. Come on. It's so sticky, it doesn't want, the backing doesn't want to come off. Wow, that's sticky stuff. Whoa, hold on. Get off there. There we go. Oh. Hold on there for about 20 seconds. It's never coming off. There's your pack. Looking good. Like I said, for purely aesthetic reasons, I put this back in. I'll throw a little padded double-sided adhesive in there. Might not need it. Let's see how tight it is. Sometimes you do, sometimes you don't. Yeah, it's fine. Yeah, it's still a tight fit. So there you go. Pack. Let's see. Yeah, look at there. It's a new pack. Barely even tell it was in there. I actually put the charging circuit here for a reason, is to avoid accidentally trying to charge it while it's being discharged. That's a bad thing. So this way you can either be discharging or charging it. So that's it. Charge this overnight and box it up and ship it off tomorrow. So yay. I want to thank again a patron from Chicago who sent this in to get worked on, and apparently he watches all these videos, so I'm very happy about that. And it turned out really well. I think this is the 4th or 5th Nomad I've worked on. I've worked on quite a few Nomads, a couple Genesis, a bunch of 5200 controllers, ColecoVision, Arcadia, several 5200s, a couple 7800s. So Nomad, one of the more popular products, and a bunch of Game Gears. So Sega's been good to me. So thanks for watching. Hopefully you found these useful, entertaining, or tolerable, whichever you prefer, and I'm going to charge this overnight. And that's it for this series of What's on My Workbench. Next up, I'm going to have is a 386 computer I'm fixing the VGA out on, and then some sound upgrades and a couple other things. I don't know them off the top of my head, so gotta look forward to that. A couple days that someone else sending in from California, so that's coming soon. And that'll do it for now. Thanks for watching.